All right, it is 9 o'clock. Let's kick off. Welcome again officially to the JUMPSTART by Medtronic in this year, 2020. Excited to have so many people join us from across the world, really, in many cases, to this virtual event. We would prefer to be in person, certainly. It's wonderful to be able to connect face-to-face. But I'm really, really excited that we've had this much interest in individuals coming together to kick off the 2020 and 2021 season of FIRST here in Minnesota and across the world. So thank you again for joining. To kick off our day, just want to talk about the virtual engagement and how we plan to jumpstart this particular time. As you know, we have 3 Saturdays coming up in the fall. Rather than one long day like we had the in-person, we've broken it into 3 Saturdays. So this is the first, October 31st, again, November 14th, and December 5th will be 2 more sessions. So rather than a long day, we're doing 3 morning sessions on these Saturdays. Today, we're very fortunate to have a keynote by Mike Hess and Dean Kamen. Just to know what to expect during the calls, we expect that the audience will remain on mute just because there are so many on this particular Zoom call. We know, again, that many are teams. So while there are 60 or 70 Zoom calls coming in, we know that there are many that have multiple team members behind the cameras there. So we are encouraging you to use the chat and keep a vibrant, active Q&A working through the keynote here. Videos are welcome to be on as bandwidth allows. I don't see any trouble so far with bandwidth. So seeing your faces, seeing your backgrounds brings us all to life, and we appreciate that. And we will moderate some Q&A at the end of the keynote. When we're finished with the keynote, there will be 2 rounds of learning sessions. The first will begin at about 10:05. We will need a little bit of transition time to get people from one Zoom call into the next. And then there'll be a second round of learning around 11 o'clock. For those, we ask again that you mute during those presentations and use the chat for questions, but we will have open mic for Q&A at the end of that. Again, video's on with the bandwidth that allows it. Again, that should not be a problem. All these sessions, I do want to mention, the sessions are being recorded for training purposes. So if you prefer not to have your video on a recording, then certainly keep that off at this point. But that content, audio, video will be captured and shared outside the event and is made to be a knowledge exchange and sharing activity. And they will be available at the jumpstartrobotics.org website sometime after the event. With that, this is really an effort of cooperation at its finest. We have a team of partners that pull off this Jumpstart every year. So it's new. Last year was the first year that we did Medtronic. So this is the second year of a Jumpstart by Medtronic. Prior to that, the Central Minnesota Robotics Hub has been the beginnings of this Jumpstart effort. And in partnership with people like Corey Applegate, Todd Cruz, Alex Jurek, those are the individuals, as well as others on that Central Minnesota Robotics Hub that have come together to put on these learning sessions for teams and getting teams up and running. Again, the sponsors you see there are Medtronic, Delta Modtech, and St. Cloud State is an obvious partner who has started Jumpstart in the past. Many thanks. The sponsors are great, but really I want to call out specific attention to those who have stepped forward to present. And you as attendees, people who are willing to get up in the morning, try something new in this virtual space. I've often said that 2020 is a year of improv, and this is another example of that. We're doing new things in new ways to work in a new normal. So thank you for coming together and being patient with us as we work a new program. Excited to have 42 teams that have registered for the Jumpstart sessions that included 401 students and 140 adults. That have committed to being part of these 3 different Saturdays. Again, multiple states and outside the U.S., those 3 dates, over 40 plus different learning sessions that are still evolving. Again, we're improvising as we go. As you have different content or different things pop up, we're able to add to our agendas in the November and December timeframes or do some virtual recording type activities too. So bringing on that learning, that's what it's all about. Again, those keynotes, live streams, demos, networking. We hope to do a product fair from Medtronic's products in the December timeframe. and more as it evolves. And again, all is virtual and recorded this year. One thing I like to mention, gracious professionalism is also, a key for the FIRST Robotics. Please consider treating others with respect. I have no doubt with the folks on this call that we are going to have respect for our presenters. Respect in the Zoom. Make sure your backgrounds and you're doing the appropriate etiquette in the Zoom calls. Those volunteers, ask for help if you need help. We have moderators that are in each of the rooms, Medtronic folks and others, volunteers who are helping in the different sessions. Respect each other, network, meet people, stretch a little. I know it's a little different working in this environment. We encourage you to reach out to at least one other person or several other to work the network. And then also respect yourself. This is a time for you to come together. We put on a great program, lots of learning, and we hope you engage in that learning and have a lot of fun. With that, without further ado, we have two really strong keynote speakers who have volunteered their Saturday to join us in this effort. Medtronic and FIRST Robotics go back quite a long ways to inspire and recognize science and technology. And with that, we have Mike Hess, who is our Vice President of Corporate Technology and Innovation, to share a little bit about Medtronic. And we will then, we're delighted and ecstatic to have Dean Kamen also join us live from his location. As all of you should know, he is the founder of FIRST and a strong inventor and entrepreneur as well. So without further ado, Mike, if you want to switch the slides and grab the ball, it's all yours.
Great, thanks, Sherry. You guys hear me okay?
I can hear you a little soft in my mind, but I can turn up my volume.
All right, I'll try to talk up a little bit more then. Well, good morning, everyone. I'm going to spend a little bit of time talking about Medtronic and how Medtronic approaches our work in the design area for medical devices, and how it relates a bit to the work and the design of the FIRST Robotics program. And then we'll have some time afterwards to talk with Dean and ask him some questions. And hopefully you guys can then contribute at that same time with using the chat feature to ask questions yourselves, and we can get those into the flow of the discussion. So hopefully we'll have a really good interactive session here. Just a little bit about me. I've been at Medtronic for over 30 years. Biomedical engineering, software engineering. I've done a bunch of things in the R&D space. That is my Medtronic ID badge. So that picture was taken a good 10 years before any of the FIRST Robotics team folks on these calls were born. Please don't tell Medtronic security that my badge is that old, because I'll make you get a new picture. But I've done a bunch of other things at Medtronic and done some invention with patents and things, and really had a really rich experience and seen how the power of the company to innovate and to solve problems in healthcare has really come to pass these past several decades. So talking about Medtronic, many of those people in Minnesota have heard a lot about Medtronic, and you may know people that work here or people in your family have worked here. But Medtronic is the largest pure medical device company in the world, and very broad in our approach to healthcare problems, solutions, and therapies. And we really have a tremendous culture of technical innovation and trying to solve problems. And I'll talk a little about how we do that here in medtech and med device. But first, I'm going to start with an interesting connection to Halloween. So obviously today's Halloween. Well, it was Halloween in 1957 that Medtronic got its start. And the reason is because there was a tremendous storm. And this tremendous storm knocked out power to a huge part of Minnesota. It took out Minneapolis, St. Paul. You can see the Wisconsin there on the little picture. So Friday morning, the newspaper report talking about this dramatic power failure and the lights going out, and University of Minnesota, dramatic, and very, very damaging. But one of the people that impacts of this was at the hospital, the University of Minnesota, where the pacemakers at the time were used line power. So basically, this was a man who was using a pacemaker. That's a pacemaker he's pushing in front of him on that cart, that big piece of electronics, and there's a cord that goes back to the wall that keeps him plugged in. So when the power failed, the pacemakers that people were using in the hospital failed as well. And the surgeon that was in charge of this said, this just can't happen again. This was a disaster. So he asked Medtronic's co-founder, Earl Bakken, I need you to fix this for me. I need a battery-powered pacemaker. Now, this is where it gets interesting, because when he said a battery-powered pacemaker, he was thinking about, here, I got this cart, on the bottom of the cart, I need some big, like, car batteries down here. Plug this thing in, put the car batteries down here so that when the power fails, I've got a backup battery. Well, Earl Bakken was a very gifted engineer, a very creative guy, and he thought, I can do better than that. And he had recently seen in a popular science magazine a schematic for a metronome. We thought, a metronome is kind of like the heart, kind of like how it beats. And so Earl came back and built instead this small transistor-based pacemaker, had batteries, and he delivered it to the hospital for the doctor to look at. Doctor wasn't around, so he left it there and said, well, have him let me know what he thinks. I'll come back and check. And of course, this is 1957. There are no cell phones. There's no texting. There's no, emails. He's got to physically go to the hospital and meet with the doctor. And he did. And the doctor wasn't there. And he came back a couple of days later. The doctor had attached the pacemaker to a child who had been operated on the day before. So Earl's invention was literally sustaining someone's life 2 days later, with that kind of urgency. And it was a groundbreaking moment for him. And it really just affirmed his faith in med technology, which in the case of pacemakers then led to a fairly rapid, adoption of these small kind of external pacemakers that this patient is holding right there that were used pretty widely for quite a while. And external pacemakers were the way it was done for quite a while, for many years. But as technology improved, the pacemakers improved. And so starting in the late 50s with that little external attachment with little dials on it the patient held onto and walked around with, we went to our first implantable pacemakers in the 1960s, which you can see were kind of like covered in epoxy. And then in the 80s, pacemakers started getting a little smarter and figuring out what the patient needed as far as how fast they should go. In 2011, we were really excited to bring out pacemakers that can go through MRI machines, because lots of patients need MRIs for different reasons. And now our newest pacemaker, which you see there on the end, is literally the size of a big pill. It's like the size of a capsule you could swallow. And the pacemaker is put in the heart. You never can see it, you don't feel it. And it does so much more than the previous pacemakers did, and it can last for more than 10 years. So we've seen just this traumatic improvement in this area of pacemakers that started with this need back in 1957 because of a lightning storm on Halloween. So it really is a dramatic example of where the inspired need led to a tremendous role of innovation. And we're really pleased. Earl Bakken passed away a couple of years ago, but he saw all of these milestones. Earl had a pacemaker, several Medtronic pacemakers, but he got to see the Micra there on the end, the pill-sized pacemaker, and he was just amazed and astounded to see what had happened technologically, and we were really proud to be able to show him that. So as I mentioned before, Medtronic is a large company. We have more than 90,000 employees. We operate 150 countries. We have manufacturing and distribution R&D sites all around the world. We've got just north of 10,000 scientists and engineers that are in R&D jobs across the company, working on new products, working with customers, and then a bunch of other people that are manufacturing and distributing and supporting our products on all kinds of other function areas like quality and regulatory, for example, working with FDA. So it's a very sophisticated and very established company, and we get a lot of benefits working across the company, solving similar problems for different kinds of healthcare needs. We also focus on making sure it's a good place to work, and we've been recognized pretty steadily here with some very prestigious awards and recognitions as far as being a company that recognizes the worth of employees and it makes it good to work here, and people tend to stay around for a long time. Not everyone stays for 30 years like me, but a lot of people stay for quite a while because it's a great place to work. So I'm going to talk a little bit about how Medtronic does the work that we do, and I'm going to talk about how we get to design, because I think that one of the great benefits of FIRST Robotics is the opportunity to do some design work and to work as teams, and those things are so important in the space that we operate in here. So we talk about designs. One of the first things that you'll hear if you go this way in your education path is, what's the need in this term, voice of the customer? Voice of the customer really means understanding what the end user really needs in their product, and not necessarily what they want in the product, but what they need in the product. And the difference there is people may ask for something very specific, but they're only asking for it because they don't know what options are available to them. So they may say, I want this. And if you ask them why they want it, and they tell you like, oh, well, you know what, I've got a better idea for you than that. And that's how we've gotten many of our improvements is doctors have said, I really want this, and we ask them why. And then we say, oh, well, if that's the problem you have, I've got better ways to solve it for you. And so that becomes a really valuable and really enjoyable discussion. And that's what really starts the discussion is, what are the needs in the clinic? What are the needs in the hospital? What do our doctors or patients say they really need help with? From that, there's this very, comprehensive discussion about what can we do? Okay, here's what they want. What can we do about it? And we've got scientists and engineers, people in marketing, we've got people in manufacturing, all of whom contribute to figure out what can we actually put together here that will be a better solution than what they have right now. And this can take quite a while. Sometimes it can take several years sometimes to get to the right answer of what you want to try to build and bring out to the market. But when you're done, you have some pretty innovative and exciting products. And we in Medtronic are doing everything from insulin pumps and pacemakers to power consoles in hospitals. You see in the bottom there, robotics is one of the most quickly growing areas of healthcare. Medtronic has several companies in Medtronic that are developed robots. There are many companies outside that are investing in robotics, and really you're seeing this as the future for many, many surgeries is to have robotically aided surgeries. And so some of the work that you're doing here, you're learning a lot about a technology which is only going to be more important as time goes on. So it's bringing together that unmet need from the customer with what the company can do and the engineers and scientists can do to really bring these great ideas to bear. So what do you have, if you hit these designers, what would you say are the characteristics? I get asked this question a lot, like, what do you look for in new employees or designers? And I would say that, these are three attributes that I think are critical really for anyone to be successful in this area. And one is, curiosity. You've got to be able to ask those questions. So to my earlier point, it's not just enough for someone to tell you what they want, but you have to ask those questions and figure out what's underlying, what's really the reason for the request. You have to be really good at teamwork, and I know that teamwork is a really strong hallmark of FIRST Robotics, but you have to be able to divide up the work, figure out people's strengths and weaknesses, and put together teams that will be very successful and complement each other and support each other at all the time. And lastly, you got to not be afraid to try new things. And there's a lot of people who are, maybe afraid of risk. They don't want to try things that are new, but, it's such an important skill to be able to try things and to understand, you can taste a new food, for example, and it's not gonna kill you, right? So you learn these new things that way. And so these become, I think, just foundational skills and behaviors that, are evident when you have a successful team or a successful engineer or designer working in these areas. At the same time, this is about good designers. Well, what do companies have? And I think, again, it's really great to be involved with robotics because there's, I think, super examples here of where the principles of like cooperation and gracious professionalism show up in the corporate world as well. Just two examples from Medtronic's standpoint. As the COVID-19 started rolling out across the country, you may have heard about ventilators, these machines that are used in hospitals to support people, many of whom were very sick with COVID-19. And ventilators became limited. There were just not, they weren't enough of them to supply all that we might need. And factories started building them faster, but you can only build so many. So Medtronic actually took the specs for our previous generation ventilator and just put them out in the world for everyone to take. We gave all our specs, all the code, all the design, all the schematics. Anyone with the technology could take these designs and go build a ventilator using these specs. And other companies did. In fact, we had over 100,000 people download the specs for this ventilator. And several companies took it, worked with us, and built up production and are now making ventilators to supply more of them. So Medtronic felt it was more important to help the world's supply of ventilators grow than it was to worry about holding on to the design that we had here. So we basically thought it was, we worked with other companies that would be competitors in some spaces of ours and said, let's get you, building this product that the world really needs more of. Another example in terms of grace professionalism is that we do focus a lot on what it's like to work here. And so, an annual report's talking about global inclusion, diversity, and equity. So are we treating all the employees fairly? Are we doing a good job representing the customers that we have around the world? What are the diversity metrics of the company? This really speaks to a company that wants to make sure it's a rewarding place to work and it reflects society in general and gives everyone a fair chance to advance and succeed. And so these things have been really important for us as you go forward here to think about the big picture, think about healthcare. Medtronic's a mission-focused company, so we also like to think about, what's the right thing for society. And certainly the ventilator is a good example where we thought the right thing to do here is to partner with other companies and help meet the needs of society. So if you look at Medtronic and that background of the kind of products we build and how we design things, who do we actually hire? Who do we bring into the company to try to get these great products built? So I've mentioned before, I've been here for many, many years. We go to really top universities around the world and recruit in all kinds of areas: finance, marketing, legal, engineering, scientists. I'm going to talk a little bit about engineering and scientists more specifically here because of the focus of First Robotics. But we go out every year and go to the top engineering schools and meet with really top students who we're looking for summer internships, and we try to get them into Medtronic. We have internship slots all over the country in terms of different Medtronic businesses, whether it's Los Angeles or Boston or Minnesota or Jacksonville, the Bay Area. And they have a fantastic experience in the summer to learn what it's like to work in a medical device company in Medtronic. They put on project teams, they're given assignments, they have a supervisor, they have technical experts that they meet with, and they get the mentoring, and then they also get a chance to meet and network across the company. Our CEO spends time with the interns every summer and talks about what Medtronic is like, in a Zoom or in person as needed. They get to see other areas of Medtronic's product. They get to present their work to Medtronic employees as they leave on the summer. And they get exposed to other parts I mentioned before, like the quality group and like regulatory, maybe manufacturing. So they get a good idea of, what it's really like to be in the company besides just the engineering. And what we try to do as employees leave after their second summer, before they go back for the last year of school, is we try to make job offers for some people. So people leave Medtronic at the end of their end of their junior year summer. So as they're heading back for seniors year, many of them head back to University of Minnesota or other great schools with a job offer in hand from Medtronic to come back the following summer. And that's how we like to kind of give the employees a chance to test drive Medtronic and give Medtronic a chance to kind of learn what the employees can do and how they work in our culture. So we've done that very successfully the past number of years. And this past summer was interesting because everything was virtual. And this was a real challenge. And we had really, a lot of discussion. How are we going to do this? And we ended up establishing a virtual intern program where the students were able to be on the job in their homes. And sometimes this meant that they had to get a computer sent to them, for example, with some special software. But we had employees where we shipped them test equipment. We tested them, set them equipment or machinery or parts, and they had to do work. And some of them set up these great little labs in their basements or garages or bedrooms and kind of like a little Medtronic outpost. And they worked all summer on these projects, and they were in tight contact with the engineers and scientists who, for most of our offices are also working in their homes or limited on-site participation right now. So really very resourceful and very resilient and had phenomenal results. We had really, really positive feedback from the interns this past summer, even doing it virtually. And I think a lot of it had to do with the quality of the folks that they were working with back in the office, right? The people they were interacting with who really wanted to make them successful, who were interacting with them all the time, who gave them meaningful, interesting work to do so they can go back to school having learned something at Medtronic, but also having learned something about Medtronic as far as how it is to work there and what the people are like. And really many of them left with enthusiasm, and again, many left with offers to come back next summer, and hopefully we'll be in person and they'll be on site, but they have this already positive experience with Medtronic they want to go forward with. So in closing, when you think about the connection here with Medtronic and the connection to First Robotics, Medtronic gives people a chance to really make their mark in terms of helping with healthcare, helping with medtech, and helping society in that respect. First Robotics, I think, gives you a chance to do that. At the same time, you can have a lot of fun. And so we're really thrilled to partner with First Robotics and to really see the great work you guys have done and the teamwork. It's great to have so many of you on this call today, participating and getting excited about the start. And we're going to continue the discussion now here by pulling in Dean, as Shar mentioned before, and talk more about his experiences and his visions and hopes for some of this design work as it goes forward here. So I'm really happy, just thrilled to have Dean on this call. As Shar mentioned, Dean is the founder of FIRST. Dean is also one of the most prolific inventors and entrepreneurs that anyone has ever met. He's obviously well known for some pretty high profile inventions, most notably Segway, but so many other things in the medical device space, mobility systems, robotics. If you go look, you'll find that his name appears on well more than 1,000 patents. So having a few dozen patents myself, knowing that patents are required to be novel and not done before, 1,000 patents is just an astounding accomplishment and just speaks to a almost unmatched kind of innovative perspective on things. And so Dean's just a phenomenal, just a phenomenal champion for the kind of work we're talking about here. So I'm going to kick it off by asking Dean some questions, and then if you guys can put some questions into the chat as well, we'd like to hear from you as well. But Dean, maybe just to start, we talked about this a little bit, but as you think about where we are right now in society and kind of the challenges ahead of us, what do you think are the most important challenges that we want entrepreneurs to be facing and focusing on to solve problems?
Well, first of all, thanks for the very kind introduction, Mike. But I would say answering that question, you made very, very easy, because I thought you gave an incredibly insightful overview of what it takes to be an innovator. And you used as a fantastic example your founder and his original experience interfacing with docs, and went on again to talk about many of the processes that your company has used, and the proof that it works is, as you pointed out, Medtronic is the largest medical product developer, designer, producer in the world. But just to recap a couple of the things you said and violently agree with them, just as your founder realized that if you ask a doctor what they want, they'll typically give you an answer which really is not a statement of the solution they're looking for. It's a kind of, typically it's a statement of what their problem is without knowing what the opportunity to solve it is. And a very clear and funny way to capture that statement is a well-known phrase, which is that Henry Ford said, "I don't do customer interviews, because if I were asking all the people out there, what do you want?" they would answer a faster horse, because the only thing they knew about was horses, and they didn't want a faster horse. They didn't know that. They wanted a car. And even the first decade or two, cars were called by many people horseless carriages, because people always make analogies to what they already know and they're reluctant to change. And innovation is actually the most difficult aspect of innovation. Isn't coming up with the technology, it's convincing people that the change to go to a new and potentially unknown environment is risky and hard. So your first statements about Earl pointing out that as he talks to docs, and you pointed out that Medtronic continues that, you don't really ask them what they want. You ask them what their problem is, and then hopefully a good innovator can bring a completely different tool set to the table, and maybe solve that problem in a way that the person that presented the problem isn't even aware of. And that intersection of new technologies applied to old problems and old ways of thinking is what innovation's about. The second point you made that I thought was right on, but I'll make it more brutally, was you pointed out that in order to succeed in innovation, then you had a slide there and you talked about teamwork, and of course that's important, and curiosity, and that's important. But you said, sort of a willingness to try new things. But what you didn't say, and I think it's important, and I think it's one of the most powerful things that kids learn when they are involved in FIRST, is inherent, unavoidable when you're trying new things, is you're going to fail. And you'll fail in ways you never thought about. You'll have surprising kinds of failures, some of which are funny. And I think one of the reasons FIRST works so well is, and I'm sure Mike, you'll agree with this, when you're in your lab trying to develop a new product, potentially to implant in somebody, to save somebody's life, the idea of failures just isn't an option. So the development of medical products is very serious, and the pressure is very high, and all the work you have to do, not only to make sure something will work, but make sure that it will not fail, is high stress work. But the process of innovating, by which you inevitably start out with failures, I think is great inside FIRST. I personally believe the reason that we have so many great mentors from industry across the country, and in particular, look at Medtronic. I think the reason that FIRST retains not just the kids' attention and excitement, but the mentors, is because it's a place where you can have fun, you can have a release, you can do all of that innovating. And if that little black box in your robot smokes, if that wheel falls off that robot, if something crazy happens, nobody got hurt, nobody died. You weren't making a product that somebody is depending on tomorrow to live. So it adds an element of fun that you typically have to be a little bit cautious about, when, especially in medical product development. It also adds an element of spontaneity, and I'm sure, Mike, you'll point out that most of the projects you people work on and that I work on tend to be overnight instant successes after 5 or 10 years of development. Whereas in FIRST, kids get to play with technology, and in 6 or 7 weeks, they open up a kit of parts. It's intimidating. What is this pile of stuff? Then they rummage through it and they find out there isn't a manual in the bottom with the assembly instructions. It's not at all like what they have in school, which is the textbook, which are all the great questions that have already been answered, and then all the answers already written in the back of the book. No, we're saying you got a pile of stuff here. There is no set of instructions. There is no path to innovation. There is no right answer. It's very, very different than the analysis you do in an academic environment. The word analysis, break it all down into something you know and understand. The opposite of analysis is synthesis. Build something up. But we're asking kids to build something up that never existed before. And that requires that they innovate. They try something they've never tried before. They do something they've never done before. And I think even for our mentors, it's an energizing experience to be able to do that in a fun environment where failure is a little more acceptable than in their serious day jobs. But it may, and for many of the kids on the teams, it may be the very, very first time they actually got to do something with adults, with teachers, with mentors, with experts in the world of science and technology and engineering, where they realize it's open-ended and exciting. It's just like when you play a sport, you don't know who's going to win that game until the end of the game. And no matter how many more games you play, every game's exciting because the outcome is not known. The answer isn't in the back of the book. That's why I chose the sports model for FIRST. And I think everything you said in what I thought was a fantastic overview, Mike, you've got to be curious. You got to have teamwork. You got to be willing to try new things and fail. Everything you talked about that happens at Medtronic, I think FIRST is just a microcosm of that. It's a way to give kids the opportunity to see what the world of science and technology and engineering and inventing and innovation could be like if they chose to develop that muscle hanging between their ears in our sport. And as you did, by the way, Mike, you plugged Medtronic and said, and at the end of a year or two, they might leave our internships with a job offer, I got to tell you, my little company, DECA, is much, much, much smaller. It's a tiny version of Medtronic. I have about 800 engineers, but almost all the recruiting we do these days is through our internship program. And we do exactly the same thing. And by the way, most of our interns these days come from FIRST teams because we get to know them there. They get to know us through FIRST. So I would start out by just saying, Mike, that was a great introduction to Medtronic and a great introduction to FIRST. And I love the fact that Medtronic has been such a fantastic supporter of FIRST over the years. But I violently agree with just about everything you said.
Thanks, Dean. And certainly you mentioned a couple of things about how you chose, why you chose FIRST in robotics and kind of constructing it as a competition. And as you were talking about the lack of instructions, I was reminded about how nowadays how hard it is to find a box of Legos that doesn't have a floor plan, right? When I was a kid, Legos were just kind of like this generic pile of colored blocks. You had to figure out what to build. And now it's kind of like, attach this to this and you end up building a little shop or something. And so I think FIRST Robotics is nice that it gives kids that kind of less structured approach to build something and have to figure it out as they go versus making sure they're following the instructions. But looking forward, talking about robotics is one thing. What do you think robotics is a big technology trend. We're seeing it kind of grow in its adoption and everything from manufacturing to medical. What are the big technology trends you think are coming next that are also going to have that kind of impact across many parts of society?
Once again, I'll refer to what I thought was your fantastic example in your opening overview, which is, I think the world of medical technology is moving at an accelerating pace, not to simply treat a condition, but to cure it. And I think holistically, think about this. No problem can ever be solved until you identify it. So even in healthcare, it's, the Greeks knew what diabetes was. They named it because frankly, they would notice that people that had what we now call diabetes, when they urinated, flies would be attracted to it. They realized that sugar was coming out of these people and it wasn't coming out of people that didn't have it. I think there's basically four aspects or four steps of dealing with, how do you innovate? One is you have to identify a problem. That we've done across many, many medical conditions. Then the next step that people do is try to treat it. Typically, we chronically treat things until we find a better solution. Well, what's a better solution than treating a medical problem? Curing it. As an example, of course, when somebody has kidneys that don't work, and they would die if you couldn't give them the cleaning of their blood, which is what the kidney does. So you find an artificial way to do it. Another business you guys were in early days, you build a dialysis machine that serves as a kidney. But that's a chronic treatment. People need that every other day or sometimes every day for the rest of their life because you're treating it. Well, what's better than treating it? How about if you could give them a kidney transplant? They come in to a hospital and their kidneys don't work. They leave with a replacement part and now their kidneys work again. You've cured it. I've never met a patient that likes a chronic treatment. People would much rather, if they have any condition, be cured. Well, what's better than a cure? Well, how about a prevention in the first place? And Albert Einstein had famously said, smart people solve problems. Geniuses prevent them. So I think there's four aspects of this whole process on any given issue. First, you have to be able to properly identify a problem. Then you stop it from hurting or killing people. You treat it. Then you find a way to eliminate it. You cure it. And then when you're really smart, you figure out a way to prevent it in the first place. And I think your example of again, what Earl did, he took a giant machine that was essentially a treatment device that a guy is connected to in your very first picture, and he's pushing this giant cart around, and it's treating the fact that his heart isn't working properly, so this machine is doing it for him. But he's chronically attached to this thing that's changing his life. And then once they made him smaller, and smaller till you could implant them. That's kind of a cure. And then they made it so small, as you saw, that you could almost put it in a way that's not very traumatic at all. In the last 10 years, that's for all practical purposes a cure. So I think the long answer to your question, what do I think is going on? I think people now have an expectation that was once considered the miracles of medical technology, the treatments we could create. I built dialysis machines. I built insulin pumps many years ago. You build them now. You build all sorts of equipment that treat people, and they're very happy to have them as an alternative. But I think people are now expecting, I don't want to be treated. I want to be cured. Or I don't even want to have to deal with this. I want it prevented. Look where we are now with COVID. We have a lot of big companies trying to work on treatments, therapeutics, but we're working mostly on vaccines. Vaccines prevent the problem in the first place. So I'd say, again, the long answer to your question, where do I see technology going? I think the next generation of engineers are going to be more focused on curing conditions and eliminating the need for chronic treatment, or preventing them by really understanding what fundamentally is the process by which we end up needing to treat something. And I think the two huge advantages of bringing that mentality to the world of innovation in healthcare is two. One is nobody likes a chronic treatment. They accept it because it's the best alternative, but they will all rather move to the next level, raise the bar. That's what technology is supposed to do. They all want that cure. The other big advantage of giving people the cure is right now, almost 100%, certainly more than 90% of the budget for healthcare in our country and around the world is the chronic treatment. It's enormously expensive to give people chronic treatments all the time. Whereas if you give them a one episode, whether it's a surgical procedure in the hospital, by whatever other means, if you can cure a condition over the lifetime of that patient, the cost will be way lower. So as we move to an innovative new era of curing conditions or preventing conditions, I think people will have a better quality of life and will prevent our healthcare system from bankrupting the country.
That's great. And I'm going to pivot to a different technology and then talk. I'll answer first, and Dean, asked for your comments too. One of the questions that came through was about how Medtronic's using AI and artificial intelligence. And so I will talk a bit about that. And first, I'll kind of level it that, for those of you who don't know exactly much about AI, artificial intelligence, we tend to think about the sci-fi, walking around the robots, kind of that kind of artificial intelligence, the sentient beings. But the reality is, the AI that we're using every day, whether it's your Amazon, shopping guide, or your Netflix queue, or your Google Maps, that's AI in our world. That's the massive amounts of data being analyzed and simplified, and choosing complicated results from all this kind of disparate input. So Medtronic actually has a number of approaches right now that we're using for AI. So we're using it in our diabetes business to actually try to figure out, when patients should have their insulin levels adjusted. Something as simple, relatively simple, as looking at what their historical levels have been, adjusting accordingly. But we have a company in Israel that's actually trying to look at what you're eating visually and figure out what it is and plan according to that, just recognizing the food versus having you put in a bunch of, of numbers into to an app, for example. We have some pretty cool technology looking at images from surgeries or images from inside the body and figuring out which images should a doctor look at and which ones should they not look at, which ones are not a good use of their time. And we're also interested in the area of robotics, trying to meld some of our imaging and navigation technologies with the robot itself. So we will get to a point in time where an image taken of the patient before they are sick, can be used to tell the robot what to do. And then basically the feedback from the robot will make the surgery happen even more automatically. So artificial intelligence is just exploding in med tech in terms of making these devices smarter, and also on the front end helping us figure out who needs these devices in the first place. And that's the other big opportunity, is when you have thousands or hundreds of thousands of patients get some kind of treatment, you get a pretty good idea of where it worked and where it didn't work. And so that makes the 100,001 patient maybe a better decision, because now based on the previous experience, what's likely to be successful or not. And so you're seeing a lot of focus right now with hospitals and doctors and insurance companies and healthcare providers and medical device companies to figure out, where does it work and where does it not work? How can we get better at using our technologies and using our therapies? So AI is a big part of Medtronic's future and a big part of our strategy now, and it's a big part of healthcare and medtech in general. Dee, I'd love to have your thoughts in terms of where you see the big, besides the med, we just talked about the med device piece, where do you see AI really being a major impactor for our society-wise?
Once again, I think you just brought up some very real applications. And maybe this is just a pet peeve I have, which is in part why I started first, which is I want more people to understand technology, whether they become engineers or not. Just to be a responsible citizen, you need to understand, mathematics is beautiful, it's logical, it's consistent, it's a good tool, it's a good exercise to understand mathematics, whether you're going to be a mathematician or not. And it's important for people to understand what technology can and can't do. And I think in that regard, I've always been frustrated that, for instance, in mathematics, we went from whole numbers, 1, 2, 3, counting numbers, natural numbers, and then we went to fractions, and then we went to real numbers. And then suddenly we called a number an imaginary number, when really it should have been called, which is what it is, a complex number, a number that can't be on a line, it comes out of the plane. But trigonometry isn't imaginary, and numbers that have the properties of complex numbers aren't imaginary, because it makes non-mathematical people think it's somehow spiritual or not real or something, and it did a disservice. In the very same way, we're living now at a time when the word artificial intelligence, I think, is having the same effect on people that don't use it, that don't understand it. And I would say to you, by analogy, everybody, for 1,000 years, all labor was manual. And, 100 years ago, you had a shovel and you had to dig ditches by hand. But when they came along with the steam engine, and when they came along and built bulldozers, we didn't call a bulldozer artificial muscle, because a bulldozer is not artificial muscle. A bulldozer will move rocks just the way you do. Newton's laws, F equals ma. A bulldozer is nothing artificial. A bulldozer does something that's very comprehensible and understandable by Newton's laws. It simply can move 1,000 times as much stuff as one person can. It's an enormously powerful tool, but there's nothing artificial or magical about it. In the same way, calling it artificial intelligence has two problems. It's not artificial, it's real. And it's not intelligence in some spiritual way. Humans solve a lot of problems by looking for patterns in things. Well, now that data can be collected in massive amounts and it can be sorted instantly, a human brain does it maybe more efficiently, so we don't have quite the brute force power of a computer. But while we may do sorting and comparing and pattern recognition in a very efficient way, we've grown up with years of experience doing it, we have now a way to do it the way a bulldozer has the same capabilities to move rocks. And I think if we explain to the public more effectively, you could take a computer, and it's always super fast these days. It can always look at megabytes or terabytes of data, and we're finding better and better ways to understand how to look for patterns and use patterns. Well, if you put all of that stuff together, you can, in the same way that a bulldozer can move more stuff than a guy with a shovel, you can use a computer, you can use linear programming, you can use pattern recognition, you can use all sorts of big data processing to solve problems that heretofore you had to depend on a person to look at all this stuff, and hopefully by essentially the elegance of the human mind, find those patterns. But I think we should stop explaining, particularly to the general public, that it's artificial and that it's intelligence. It's a powerful, well understood set of tools that's developing and getting better and better all the time. And just like it would be silly these days to ask somebody, where do you think we'll use computers? They all say 40 years ago, people said, nobody will ever have a computer in their house. Now you don't have anything on you, including your watch, your iPhone, your television set, your refrigerator. You don't have anything that doesn't have computers in it. It would be silly to ask the question, where will we use computers? I think it's about as silly to say, where will we use artificial intelligence? It's the answer to your question. I think there is, we will use better computing tools, faster process of data analysis in every kind of product we make and use, because the processes are getting simpler, more power efficient, and cheaper. The library of capabilities to do the kinds of pattern recognition that we use in artificial intelligence are getting better. So we use artificial intelligence in the design of a lot of the products we're working on now. We're building autonomous robots with FedEx for delivery. We're making other medical products that we're taking massive amounts of data in from various clinical situations and using that data to optimize control systems. But I think over the next few years, people will just get comfortable with that as another tool. And I'm hoping we'll stop calling it artificial intelligence. We'll stop calling them imaginary numbers. We'll understand that complex numbers are a wonderful, powerful mathematical tool, and that's what they are. And artificial intelligence will lose its mystique, which I think hurts us more than helps us and makes people fear it the way they fear the science or the science fiction of all the evil people using artificial intelligence.
Yeah, those are good points. I think maybe the best testament of where the AI has been successful is when people don't realize it's actually running in the background, right? So again, I mentioned the examples of like your Amazon recommended shopping list or your Netflix queue. If you don't realize that there's a complex algorithm back there figuring out what you tend to watch and at what time you tend to watch it and recommending movies and showing you the pictures of the movie that makes it most appealing to you, you don't even know that that's AI classically behind the scenes. And so it's that creeping into society a bit at a time that I think has made it ubiquitous, and people now don't even realize how often every day they interact with these complex algorithms behind the scenes that are in that category of AI. So it is it's insidious in a good way, the way it's kind of permeating society and hopefully making things simpler. I love your analogy. We don't call it artificial muscle, right? It's just it's scale that we can't do at a human level that has benefit for us when we direct it. But I want to go, if I go backwards, we talk about the future kind of things. We've got a bunch of students on this call, and I'd love to hear, Dean, from your perspective, when you were young, so back before Legos had instructions, what really got you inspired to be this inventor, and what really engaged you, and how did you kind of exercise the creativity in your teen years that led you where you are today?
So I guess my life was a personalized version of FIRST. I always found using a textbook useful, but it was to give me the tool. It was a shortcut. I didn't have to, and I'm not smart enough to have come up with Newton's laws. I wouldn't have derived this simple linear first order equation. F equals ma, something is proportional to something times something. Everybody thinks he's the greatest mathematician of all time. You realize F equals ma, A is equal to a constant times B. It's the simplest mathematical statement you make that's not trivial. The only thing simpler than A is equal to something times B is A equals B. Well, that's trivial. So A equals B times something. It wasn't his algebra that was brilliant. It was the insight that all the motion in the world, two atoms interacting with each other, or two galaxies, or an apple falling from a tree, F equals ma. It's an enormously powerful rule that you can apply to predict what the world will do. And Ohm's law, E equals IR, another simple first order relationship, but it allows you to know, if you know current, you know resistance, you get voltage, you get power. I love the idea that you could go to textbooks and live by, as they say, the reason Newton said he got so far is that he was standing on the shoulders of giants. And I think we as students can get the books and we can instantly absorb what took a lifetime for Newton, a lifetime for James Clerk Maxwell, a lifetime, 2,000 years ago, Archimedes' principle, we still learn it today. He gave us that fact 2,000 years ago. Most of us wouldn't figure it out on our own. So I'm not downplaying the power and the efficiency of school, but if somebody gave you a full toolbox and never let you build anything. All you ever did was learn how to use, this is a saw, this is a hammer. Well, that's great. Now I know what a saw is. Now I know what a hammer is. It doesn't have any meaning till you try to build something. And I thought as a kid, once I could see those powerful rules and those powerful tools of engineering, I wanted to use them. And I started building things, and those rules work. They're not just a good idea. They're the law, right? F equals ma. Gravity's not a good idea. It's the law. It's always there. It's very reliable. And so I loved playing with technology. I loved getting examples of it into things I was designing. And then because my older brother was going through med school, treating babies with cancer, and he needed a way to deliver precise, tiny amounts of drugs to these tiny people, I would go into my parents' basement and build them stuff. It wasn't because it was a business. It was because my brother needed something and babies needed help. But my brother would show this stuff to the docs. Yeah, he was bouncing up and back between Harvard Medical School and Yale Medical School when he was doing a guest residency at Harvard and then his full residency at Yale. And he would show his professors, and they would look at these little things. And unlike my brother, they'd pay for them. And also, they weren't treating very rare diseases like my brother treating neonates with leukemia. They were treating, for instance, a condition you guys at Medtronic know well. They were treating people with diabetes. And when my brother lent some pumps to guys and some women that were treating people with diabetes, they said it's small, it's light, it's battery operated, they can carry it around, and they'll do much better giving a patient small continuous amounts and then maybe a bolus button for meals. That's much better than the shot or two a day. That was what they had been doing for 50 years before I made these pumps. So it turned into a business. I had to move out of the basement. And then as I did more and more development for some of the docs, just like your opening statement, I would go and visit my brother and visit the docs and deliver the stuff. And I had no other business plan, but a doc would inevitably say, hey, Dean, I need you to build me this. And I'd say, well, why do you need that? And they would explain their problem. And I'd realize, I don't think he needs what he's asking for. He doesn't know that we can solve his problem in a much better way. And I started building other things like dialysis equipment, like prosthetic limbs, like artificial organs, like stents. And I would just listen to docs tell me what their problem is. Then I'd listen to them tell me what they think they needed as a solution. And then I would try to mix and match and go back to them and say, well, how about, wouldn't it be better if we could do this? And if they'd end up saying, yes, that would be better, I'd go back to my then little lab with a few people, and always lucky I got successful with some of these things. So my lab would grow and my number of people and my resources would grow. And by the time I was supposed to have graduated from college, I had a few of these products in production. And while it's only partially a joke, everybody that knows me knows I say I spent the best 5 years of my life as a freshman at WPI, which I did. I never got any credits because I was always on the campus, but I would go between the physics department and the EE department and the mechanical engineering department. And I would ask the professors how to do a specific thing that I knew the technology was capable of doing, but I didn't know how to do. And I would rather learn by really doing it and make a product out of it so I could pay tuition. And it made the technology more real to me. And so rather than sitting in class and academically learning it and maybe later applying it, I decided learning it as you're trying to solve a real problem was more real for me. And so I combined my, what's supposed to be your college, maybe academic life with my practical life. And once I was successful at that and I left, I thought, you know, a lot of kids might be way more interested in putting their time and their effort and their energy and their heart and their soul into learning the somewhat difficult aspects of mathematics and physics if they saw a better connection to how this stuff could be applied, how it could help people, how it could give them a career. And I just realized, you know, I should create an institution that might appeal to a lot of kids, particularly women and minorities that might never see the elegance and the beauty and the power of technology and mathematics and physics. That's why I started first.
That's great. Listen, we're just about out of time. Maybe just in one 1 minute, maybe Adina, one more question I'd like to ask you from your experience as we close here is, we've all been, last 6, 7, 8 months here doing everything virtually, right? We're Zooming this, we're Zooming that, we're not in person, we'd love to be in person. You've got a lot of plates spinning here all around the world as you're doing this kind of stuff, and you're sitting in your beautiful library there doing it from Zoom. And what advice, parting advice, would you give the teams and mentors and stuff on these calls to kind of stay engaged and productive when they're virtual, whether it's school or work or their first kind of teams kind of staying involved and active?
Well, in a weird way, and maybe it's just my approach to life in a weird way, that there's that old saying, every problem presents an opportunity. I think if you look at the last 6 or 8 months, the world is becoming surrounded by insurmountable opportunity. I think we have a lot of real problems, like fighting a real virus, COVID. I think we have now identified a lot of self-inflicted wounds because the process has uncovered disparities due to our social structure, that there are haves and have-nots that are diverging. In a very rich country, we have a few people that, because the power they've harnessed in technology is giving them even more capability and resources, and others falling further behind. By that same analogy I gave you, when everybody was out there competing with their shovels, there were a lot of jobs for a lot of ditch diggers. But if only a few people could have the power of a bulldozer, well, for one thing, they're going to be really capable of making a lot more holes or building a lot more roads than anybody ever could with a shovel. And in fact, then all those other people that used to be able to make a living with a shovel are going to be in trouble because they can't compete. And I think the power of technology today, like your artificial intelligence or computing, is going to make an even bigger chasm between people that have that powerful tool than the people that don't. Way more than the guy that can drive a bulldozer versus than the guy with the shovel, somebody that understands technology. And we've seen that superimposed over this COVID real problem. We've seen the social unrest because we're putting a spotlight on this other problem. I think first, ironically, is an answer to both problems. What I would ask all of our mentors and all of our parents and all of our teachers and all of our kids to do is 2 things. Realize that it's technology that's going to get rid of COVID. Look how fast they're moving these days. Everybody's frustrated. It might take a year. We lived for 1,000 years knowing about all sorts of horrible diseases that would come in seasons like polio, or we didn't even know what to call them, but the Black Plague back then, or smallpox. And they took hundreds of years to understand and develop one at a time, decades apart in the 20th century, vaccines for them. Now we suddenly uncover a brand new terrifying vaccine, and a terrifying virus, and the public demands an instant solution. I want a vaccine developed this week. I mean, our expectations are staggering because of the power of technology. So I would argue that COVID should remind everybody out there that I've been saying for 30 years, the world is getting more complex, more dense, more crowded, with more people, with more needs for energy and food and water and cybersecurity. And if we're going to, as a global community, win the battle between catastrophe and a higher standard of living, the only way we win that battle is have a better, larger army of well-equipped technologists that can stay one step ahead of the next potential catastrophe. And that's what FIRST is building, that army. The second thing I'd say is we also now should clearly understand that we've got to get women and minorities to embrace science and technology at an early age so that they can put themselves on the path to have great careers. Because if we don't, the disparity will get worse, the social inequities will get worse, and that will make society a fundamentally unstable, unsustainable situation. So I would ask everybody involved in FIRST to go out, to stay the course, if anything, accelerate your pace, but to go out and help bring new people to the tribe here. We've got to create, even in these hard times, even when it's hard to get big groups together, we've got to find virtually and online and in small groups with each other. We have to find a way to accelerate the growth and access to FIRST to every kid in this country, to every school in this country, and every company in this country should be out there demanding that their local schools create a program, and every company should be making sure that their people will become mentors for these kids, will become role models for these kids, because if we're not willing to make that kind of long-term investment, we're going to deserve what we get. So I think Medtronic ought to be held up as the poster child in Minnesota and around the country for a company that talks the talk and walks the walk. And I hope you can prove to every company you deal with and all of your associates that FIRST is a fantastic investment. It works for you as a company. It works for your community. It works for your schools. And we've got to make it more available to more people everywhere. And I just want to thank you, Medtronic, for doing what you do.
Well, it's been great. Thanks, Dean, for those thoughts. I know we got a discussion going on for a while. We got to wrap it up, but I think we got to get onto our agenda here. So with that, I'll turn it back over to Shar.
Thanks, Mike. A wonderful session, and I really, really appreciate your comments and your insights from both of you. How about a round of applause for everyone, from everyone to you. Our heartfelt thanks and gratitude to both of you for spending your Saturday with us. Really appreciate it.
Thank you.
Thank you very much. Moving forward, now we're jumping into the round one of our sessions. If I'm able to share real quick, I think I should be able to do this. Do you see my screen? I'm assuming you do. Okay, great.
Yep, that's good.
Round one, we have 5 great sessions. The rooms are there. The presenters and moderators should be getting those Zoom calls set up. Be a little patient as we transition between this and the next Zoom session, but we should be pretty prompt in getting those going. And then right at 11 o'clock, we'll jump into round 2 of the sessions that are there as well. Again, many thanks to the presenters and the attendees, everyone who has been part of this event. The next session that we have, or the next Jumpstart that we have, will be on November 14th. We've already got some really great content lined up for that, and hope that you'll join us there, as well as make sure you mark your calendar and share the news that we have December 5th on the calendar as well, with some more information and other things that will be around career and some products, fair, and some other activities, and a new agenda around that as well. All the sessions are new and fresh. With that, again, a round of applause for our keynote speakers, and we will see you in the rounds, the learning sessions. Thank you very much.